Hello genius minds, welcome back. Well, I'm uploading after a year, I guess. Anyways, let's just start with Kepler's third law of planetary motion. What is Kepler's third law of planetary motion? Kepler's third law states that the square of the time period of revolution of a planet around the sun in an elliptical orbit is directly proportional to the cube of its semi-major axis. Now here comes the question. What exactly is a semi-major axis? So let there be an ellipse. Now the longest possible line segment that can fit in this ellipse is known as its major axis. In this case, the line segment is AB. Dividing this axis or the line segment into two equal parts, we get our semi-major axis. The semi-major axis passes through both foci in an ellipse when extended. We can actually simplify this definition by replacing semi-major axis with mean radius, or we can just say radius for this instance. Anyways, back to the topic. We can represent this law symbolically by taking the revolution period as capital T and mean radius as small r. So the relation thus obtained is T square is proportional to R cube. Taking R cube from RHS to LHS, we get T square by R cube is equal to a constant. The value of this constant is taken as 4 pi square by G whole into capital M plus small m. This changes the formula to T square is equal to 4 pi square by G whole into capital M plus small m multiplied by R cube. But why the constant value is 4 pi square by G whole into M plus M? See, if we assume the orbit to be circular, then equating centripetal force to that of gravitational force acting on a body in that particular orbit, we get mr omega square is equal to G whole into small m multiplied by capital M by R square. The centripetal force mr omega square can also be written as m v square by r. Now cancelling small m on both sides, we get G capital M by r is equal to v square. Velocity v can also be written as 2 pi r by time period t. Now putting the value of v in the previous equation, we get capital G m by r is equal to 4 pi square r square by capital T square. Upon adjusting the values on both sides, we get T square is equal to 4 pi square by capital G multiplied by capital M multiplied by R cube. Thus finally we have concluded that the value of k is equal to 4 pi square by capital G multiplied by capital M whole into R cube. One point to be noted is that the small m has not been included in the original value of the constant k because the value of the small m is quite negligible to the mass of the star orbiting. That's it for this video. We have done some derivation in this video, so it might get a little tough to understand this, but anyways, thanks for watching. Bye bye.